Hi everyone, it's Miss Haley again. For today's video, I'm doing something a little bit different. I'm not going over the checkup or the study guide or anything like that. I'm going to be going over how I figure out trig values, not using the unit circle, not using really any sort of trick. This is just my strategy for figuring out exact trig values. So hopefully this is kind of a different way of thinking about trig without stressing out about the unit circle and all of that. So if you prefer the unit circle, I know a lot of people do, go ahead and use that on your quiz, but this is how I like to think of it. So I'm going to go over an example and then I'm going to kind of summarize the 3 steps that I've put this into, and then we'll do some more examples after that. So I like to use the special right triangles when talking about trig rather than memorizing the unit circle. While, memorizing the unit circle, you can definitely do it. There's tricks that you can learn on YouTube. I think this is the fastest way. Memorizing the 2 special right triangles takes about like 5 seconds to write down, rather than the whole unit circle, which takes probably at least a minute. So this is what we're going to be using. This next piece of information is new to you all. So all students take calculus. ASTC is kind of a mnemonic device that helps you remember in which quadrants each trig value are positive and negative. So in the first quadrant, the A stands for all. So in the first quadrant, all trig values are positive. So if you take the sine, cosine, tangent, or any of the reciprocal trig functions of any angle in the first quadrant, they're all going to end up positive. In the second quadrant, only sine values are positive. So in the second quadrant, if you take a tangent value or a cosine value, they're going to be negative. Only sine is going to be positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. So all students take calculus. That's a quick way to kind of remember in which quadrants which trig values are positive and negative. So then the third portion of information helps us to match radian angles with normal degree angles. So any angle with a denominator of 6 in radians will match up with 30 degrees, denominator of 4 matches up with 45 degrees, denominator of 3 matches up with 60 degrees. All right, so let's use those pieces of information and try to find our first trig value. Let's do something simple like sine of pi over 6. All right, so the first step in determining our trig value is to figure out where exactly pi over 6 is. Okay, so I know pi over 6 is 30 degrees, right? So 30 degrees is about here, so we know we're in the first quadrant. So based on that, we can look at our all students take calculus, and since we're in the first quadrant, I know that all trig values in the first quadrant are positive, so my answer is also going to be positive. So that's my first step. The second step is to match up my angle with my radian angle with the degree angle. So since I have a denominator of 6, I'm going to be looking at 30 degrees. Third step, I'm going to be finding the trig value. So since I know I'm using 30 degrees, now I just have to find the sine, and now we're done. So the sine of 30 degrees is O over H, opposite over hypotenuse, so 1 over 2. So that means the sine of pi over 6 is positive 1/2. All right, just to summarize what we just did, these are the kind of 3 steps that I always follow when using this method. First, you have to find the location of the angle to determine if the trig value is going to be positive or negative. Second, you match your radian value with the degree value. And then third is you use that degree value using that special right triangle. All right, let's move on to another example. So for number 2, let's get a little bit more challenging. So let's do the cosecant of 2 pi over 3. All right, remember my first step is to determine where my angle is. So I know if I go 180 degrees, that's equal to pi. And if I go 360 degrees, that's equal to, 2 pi. So 2 pi over 3 is not quite a full pi, right? So I know my angle is going to be about here, okay? Hopefully that made sense. If it were cosecant of pi, it would be right here, right? But since it's only 2/3 pi, it's going to be a little bit less than that. So we're in the second quadrant. So considering that, knowing all students take calculus, we're in the second quadrant. Sine is positive, but we're finding cosecant. So if sine's positive, cosecant is also positive because that's just the reciprocal of sine. So I know my answer is going to be positive. That's the first step. My second step is to determine which degree angle I'm using. I have a denominator of 3, so it looks like we're going to be looking at 60 degrees. Third step, I'm finding the cosecant of 60 degrees using my special right triangle. Cosecant is the reciprocal of sine, so instead of doing opposite over hypotenuse, we're going to be doing hypotenuse over opposite. So you can leave your answer like that. That might be what Apex prefers when you're taking your quiz. But what your math teacher next year will prefer is if you rationalize it, which means you can't leave a square root in the denominator, so you can rewrite it as 2 square root of 3 over 3. And that's what I prefer my answer to be as well. It's just more proper. Let's do another example. Again, I want to get a little bit more challenging so that you're prepared for your quiz. Let's do the cosine of 11 pi over 3. Oops. 11 pi over 3. Again, my first step is to determine where my angle is. 180 degrees is pi, 360 degrees is 2 pi. Okay, so let's think about what would 2 pi be in terms of thirds, right? That would be 6 pi over 3. If I was writing 2 pi with a denominator of 3, that would be 6 pi over 3. So that means if I go all the way around one time, that's 6 pi over 3. So then if I go around 2 times, that's 12 pi over 3. But the angle we're looking at is only 11 pi over 3, so that's slightly less. So I know my angle is somewhere down here in the fourth quadrant. So that's one way to figure out where your angle is when your angle is bigger than 2 pi. So since I know I'm in the fourth quadrant, let's look at our all students take calculus. I'm finding the cosine, and in the fourth quadrant, only cosine is positive. So I know my answer is going to be positive. So that's the first step. Second step is to determine which angle we're using in terms of degrees. Since my denominator is 3, I'm again, for this example, going to be using 60 degrees as my angle. Alright, so last step, I need to find the cosine of 60 degrees. Cosine is going to be adjacent over hypotenuse, so 1 over 2. So my answer of what is cosine of 11 pi over 3, it's 1/2. Alright, let's keep going. Let's do one with 4 in the denominator. Let's do sine of 13 pi over 4. So again, my first step is to determine where my angle is. 180 degrees is pi, 360 degrees is 2 pi. Another way to think about where your angle is to divide the hemispheres, which is the top and the bottom of the coordinate plane, into fourths. So 1, 2, 3, 4 sections in the top, 4 sections in the bottom, and that'll help me determine where my angle is. So if I go all the way around, that would be 8, right? So 9, 10, 11, 12, 13. So if you kind of divide each of the hemispheres into fourths, into thirds, or into sixths, and then count your way around, that's another way to tell where your angle is going to be. Alright, so I know my angle's in the third quadrant. In the third quadrant, only tangent is positive, and since we're taking sine, our value is going to be negative. Second step, I know my denominator is 4, so that means we're going to be looking at 45 degrees for our third step. Last step, we're finding the sine of 45 degrees, which is going to be 1 over square root of 2, or the answer I'd prefer is square root of 2 over 2, and that's, again, negative. Alright, let's keep going. Let's do 2 more examples. So in this example, let's do tangent. We haven't done that one yet. Tangent of, here we go. Tangent of 7 pi over 4. Alright, again, I need to figure out where my angle is. Here's pi, here's 2 pi. 2 pi in terms of fourths is going to be 8 pi over 4, right? But my angle is only at 7 pi over 4, so that's not quite all the way there. It's going to be in the fourth quadrant right there. Alright, in the fourth quadrant, only cosine is positive, and since we're taking tangent, I know my answer is going to be negative. Next step, since my denominator is 4, I know I'm looking at 45 degrees. So when I take the tangent of 45 degrees, that's opposite over adjacent. So my final answer is -1. Alright, next example. This is going to be my last one actually. So let's do another inverse trig function. Let's do the secant of 7 pi over 3. Alright, so I have to figure out where my angle is. Okay, so let's divide each hemisphere into thirds. I think maybe that strategy would help a lot of you. Alright, so let's count. 1, 2, 3. Oops, I went a little bit too far. 1, 2, 3, 4, 5, 6. So we went all the way around one time, and then 7/3 would be right here. So I know my angles in the first quadrant. In the first quadrant, all trig values are positive. So my answer is going to be positive. Second step, my denominator is 3, so I'm going to be looking at 60 degrees. Third step, I need to find the secant of 60 degrees. Secant is the reciprocal of cosine. So instead of doing adjacent over hypotenuse, I'm going to be doing hypotenuse over adjacent. So my final answer is just +2. Alright, so that's my method for finding trig values. I prefer using this rather than thinking about the unit circle. So let me know down in the comments if this method was helpful for you, or if you have any other questions, reach out via email or on Teams. And if there are any problems on the checkup that you want me to go over, go ahead and post those or send those to me, and I'd be more than happy to do that. So I hope this helped maybe give a little bit of a different method to finding trig values. So yeah, just let me know. Have a great day.